Hi, in this section, we're just going to briefly talk about independent and mutually exclusive events in a little more depth, just with events, not really probability. So, if two events are independent, if the occurrence of event A in a probability experiment does not affect the probability of event B, two events are dependent if the occurrence of event A affects the following event. So suppose Bucky draws a card from a standard 52 deck and then rolls a die. The events draw a heart and roll an even number. So we have two pieces. We're not using the same deck of cards for each event, right? One is going to be drawing a card, and then I'm going to roll a die. So if I draw a heart here, does that affect what number the die lands on? We're like, no, they're two different objects, right? And I would say absolutely. And since one event doesn't affect the other, this means that these two events are independent. Okay, and then if we wanted to, we could just say because rolling a die is not affected by which card is drawn. Okay, so in this next example, says suppose two animals live in the same vicinity of the jungle. The events animal 1 survives the year and animal 2 survives the year. So what's happening here? Let's draw it. So here's the jungle, and animal 1 lives here, and animal 2 lives here. If this animal lives, will this other animal most likely be able to live? Like, let's not take the food chain into consideration. Let's just think about just animals living in the same environment. Yes, right? And if something happens where there's a predator going around and now this one dies, the first animal, what's the most likely as these animals are dying over here, that whatever predator is happening is going to come over here close by and try to kill off that vicinity of animals, right? It's highly likely. Right. Let's just think about COVID-19, right? The coronavirus 19. If even though it originated somewhere in the Eastern Hemisphere, did it come here and then spread? Well, yeah, because if people were getting sick in my school that I go to, most likely it's going to spread to the next school and the next school, just like flu season, right? And so those type of things, whether they're predator animals or a disease or just a virus going through, it will be affected and the next neighboring area will be dependent on what's happening in the area next to it, right? So in this case, yeah, like these two events are dependent. Okay, and we can say, write something, right? Because if animal number 1 lives, then most likely animal 2 also lives. And similarly, if they do not survive, I'll put in parentheses. So if animal 1 doesn't survive, most likely animal 2 will not survive. And if animal 2 lives, animal 1 lives, most likely animal 2 can expect to live. So it's kind of like the same thing with, living and then dying. So. Okay, so then if we deal with mutually exclusive events, that was a little different, right? Independent event says the second event or following event isn't affected by the first event. Mutually exclusive says there's no overlapping outcomes. So if I wanted to talk about Satchel drawing a heart from the deck and the queen, let me draw a picture of what that would look like, right? So let me draw a little square and a Venn diagram. An event diagram is just two circles. I'm sure you've seen them before, and then with a little bit of an intersection. Here, what I want to do is actually grab and make a big one, actually. Okay, and then so here's the Venn diagram, and then the whole entire set here will be all the cards, right? The deck is out here. And the hearts and queen will be the little circles. So here are all the hearts and all the queens. Okay, so what do we have for hearts, right? We have 2, 3, 4, 5, 6. We have all the way out 9, 10, and then we have a jack, king, and an ace, right? Those are all the hearts that we have. But I am missing one heart, right? I have a jack, queen of hearts, king and ace. What about my queens? My queens, I have the queen of clubs. I have the queen of spades. And then I also have a queen of hearts. I'm sorry, queen of diamonds. Diamond. And then I have the queen of hearts. So notice that because, remember when Satchel drew a heart and a queen, there was overlap between the suit and the type of card. And therefore, this is the piece that makes it not mutually exclusive. So if I'm going by suits, they're mutually exclusive. If I'm going by type, they're mutually exclusive. But the moment I cross over, it becomes non-mutually exclusive. And so we can see this by the Venn diagram that there's some intersection, or in other words, overlapping in the picture. Okay, so let's kind of go more deeper in here. Let's talk about tossing a coin twice. Let's toss a fair coin twice and look at the sample space. So we talked about this in the beginning where you had a tails and a head if you tossed it once, but what if I toss it again? So here is the sample space, and if I toss, let's start with tails here, right? If I tossed a tails first, what could I toss on the second toss? Well, another tails. And if I tossed a tail first, then I could toss a heads. Okay, so now let's do heads first. If I tossed a heads first, then I could toss a tails. And if I tossed a heads first, then on the second toss, I could toss a heads. So those are the 4 outcomes for tossing a coin twice. What is the sample space for tossing at most one tail? So now I only want at most one tail. So at most one tail would be all the pieces in the sample space that only have one tail. So here is 2 tails, I can't take it. 1 tail, no tails. So I have TH because that has 1 tail. Heads, tails, and which one has at most 1 tail? Well, this has none, so that fits in perfectly because it doesn't have anything. What is the probability of tossing at most 1 tail? So now what I'm looking at is the probability of tossing at most 1 tail. So the probability of tossing at most one tail is equal to the number of outcomes of one tail at most one tail all over the total outcomes. So how many ways can I have at most one tail? Well, up here I had 3. And the total number of outcomes in my sample space was 4. Okay, now let's look at the sample space for tossing more than one tail. Does that include one tail? I want more than one. If I said I wanted more than one cookie, could you give me one or none? No, right? You need to give me more than one. So what is the sample space for more than one? So I'm looking for more than one. More than one, more than one. 2, only 1, nope. 1, no, nothing, don't forget it, right? So just the double tails. What is the probability now of tossing more than one tail? Well, it's going to be the number of ways of more than one all over the total outcomes. Okay, well, I found that to be 1 in part D out of the sample space, which had 4 outcomes, so 1/4. Okay, so we want to be careful when we start talking about these expressions of most one, more than one. If you need to brush up on your inequality or the language, I think I encourage you to really look at those phrases because they really are specific. And if you said at most one tail and you included only 2 of these outcomes, then you would have been incorrect, right? If you said more than one tail and you included all of them that had one tail, that's also incorrect, right? Because we need to understand when it says more than one, at most one. So we want to be able to understand those phrases, and that way we can do the problem correctly.